So good afternoon, everyone again. My name is Damaris Choti. I'm coordinator of student and alumni programs with the African Studies Center here at MSU. It's my pleasure to welcome you all back. For those who have been at the tea time before, and for the new members, please welcome to the African Tea Time. And today's discussion is going to be focused on the country of Ethiopia. And we have a presenter who is from Ethiopia as well. He's a graduate student in the School of Food and Packaging, and his name is Haile Duguma. I'll use the first and last name only. And as I said, he's a graduate student in School of Packaging here at Michigan State University. And Haile is also an academic faculty in the Department of Post-Harvest Management in Jimma University in Ethiopia. So the theme for our discussion today is food packaging and preservation in Africa, a look into existing systems. And the topic that Haile is going to address is its indigenous knowledge of farmer on grain storage and management practice. And that's focused in Ethiopia. So I wouldn't want to introduce him further. Haile, please feel free to say more about yourself before you begin the presentation. But what I want to do is to thank you so much for accepting to do this for us, because we know you're busy. We know you are a new student to this MSU environment, but we're really still thankful that you have work. You've done a lot of research around this theme and topic that you're going to share with us today. I won't be the facilitator for the event. I'm going to welcome our graduate student, who is Emmanuel Jimma. Emmanuel, please welcome, introduce yourself, and then go ahead and invite the speaker and facilitate the discussion. Thank you so much.
Thank you, Damaris. Hi, everyone. Like Damaris said, my name is Emmanuel Jimma. I'm a graduate student in the School of Social Work, and I am from Malawi. And I will co-facilitate this session with my fellow graduate student, Ife, who is with us. I'll let him pop in and introduce himself as we go on. And so how we'll structure our time together is allow Haile to make his presentation, and thereafter we'll engage in conversation with him on what he presents. At that point, I'll invite you all to share feedback and ask some questions. And so without further ado, Haile, this is your time to take us through this presentation that we're looking forward to.
Okay. Thank you so much. My name is Haile. I'm from Ethiopia, and in Ethiopia I have been working as a lecturer in Jimma University for 4 years, and have joined the MSU last summer to pursue my postgraduate study in packaging science. And I'm happy to join this team. And my today's topic of presentation is indigenous knowledge of farmers on maize storage and management practice. So in this presentation, I'm going to address some of the points: introduction, maize post-harvest handling practice, Ethiopian traditional maize storage, laws of maize in traditional storage structure, storage management practice that has exercised by the farmers, and finally, we will see the conclusion. To start with the introduction, globally maize is the third most important crop after rice and wheat. And it is one of the stable food grain for large parts of the world, including Africa. It is like cereal, widely used as stable food crop, and it contributes for food security for small farmer. And in Ethiopia, it is the second most widely cultivated crop next to teff, and it is also grown in diverse agroecologies. So almost all parts of the country produces maize in Ethiopia. Despite the increase in the production because of the improved varieties and technologies, the post-harvest loss is very challenging for food security in developing world, including Africa and Ethiopia. So the substantial amount of whole grain is being damaged after harvest because of lack of adequate storage and processing facilities. Still, our harvesting storage practice are manual and it is backward, so this leads to the losses of significant amount of maize that can be used to ensure food security. In many developed countries, grain storage practice involves traditional. These are very exposes the produce and leads to the deterioration of the product because of insect and other attack. Some findings indicate that the post-harvest loss of durable crop in sub-Saharan African countries to be in the ranges of 20 to 40%. This indicates that how much the post-harvest loss is severe in sub-Saharan African countries. And in some cases, it ranges 10 to 88% of the total maize produced each season in the region due to the field and storage pests. So the loss for maize started from the field and continue in the storage. For having this huge amount of post-harvest losses associated with our traditional practices, still we are using manual power starting from harvesting until it goes for consumption or storage. So this figure indicated the estimated post-harvest losses in Africa along the value chain or starting from farm to storage. As you can see, during harvesting or drying, there is bird, rodent, insect, missed grain, missing of grain in the field, excessive drying, insufficient drying are some of the causes for the losses of the maize during harvesting. And the loss during harvesting is suspected to range in 6 to 16%. Again, it depends on the season of the condition. If an erratic rain happen, it goes beyond that. The other loss is like during threshing. As you all know, still for the threshing and shelling, we are using traditional practices, and this can lead again to losses of up to 2% maize. The other is during transportation. During transportation, spillage, breakage, leakage are some of the causes that lead to the deterioration, losses of the maize. The main post-harvest losses of the maize is associated during storage. During the storage, as the product is detached from the mother tree, their capacity to resist to different insects and the other is diminished so that it can easily be attacked by insects, rodents, mold, bird insects. And the loss during storage is in the range of 4 to 10%. And the other is during transportation and the market. Again, there is a whole loss. Overall, the post-harvest losses of the maize starting from harvesting until it reaches consumption looks like, and in some cases, it is beyond this is the estimated value, and there is a probability that almost 80% of the grain damage. So different, even though there is high probability of damage, still the farmers use different management practice to minimize their maize damage by insects and other means. The finding confirmed that farmers have used different traditional methods to protect their seed from infestation with storage insects. We will see in detail what practice has been applied by farmers to minimize the infestation and post-harvest loss of the maize. And this review focuses on traditional storage management practice that could be effective in storing, controlling pests during storage. The post-harvest handling practice of the maize, as I've said in previous slide, there is a loss along the value chain, but it starts mostly from harvesting. The appropriate time of harvesting for grain is in terms of the moisture content, like it contains up to 20 to 30%. However, in developing countries, including African, we don't have equipment or facilities that can detect the appropriate moisture content for our produce. And we are still using manual means of detecting the stages of harvesting. So farmers have their own indigenous knowledge how they can harvest their produce, like visual observation, crop calendar method, shelling and observing the kernels, checking seed hardness crop for harvesting by chewing between the teeth, and in some cases they use seed drop of the heads of the maize. So farmers use, instead of having scientific method that it is inappropriate moisture content, they use their traditional knowledge to harvest their maize. And drying is another practice that farmers use their indigenous knowledge, whether that the maize is to the right dry level or not. Even though it is not accurate or it is not exact, still the farmer has their own means to detect their the right drying practice for their maize. The report indicates that farmers in Tanzania, they use biting or listening the sound of the produce of the grain, so they can know whether it is dry to the desired level by biting between the teeth. In Ghana, also the farmers report to check the maize dryness using their teeth by biting. And the report also indicates from other countries like Guatemala, the farmers use different dryness checking mechanism like fingernail test, mouse test, combination of visual and other means. The report from Kenya also indicates that the farmers use sun drying as means of mitigating insect infestation. So even though it's not to the desired level, still the farmer has their own indigenous knowledge that drying is needed for the produce to be safe during the storage. The other topic that I want to talk in this presentation is the Ethiopian traditional maize storage. The farmers in Africa usually store their produce for consumption or as a seed until they sell it to the local market. And in Ethiopia, the farmers use different storage structure for their maize. One of the storage structure is underground storage or pit. This underground storage pit is popular in dry area of the dry lands of Ethiopia, where there is a shortage of wood for the construction of Gotara or Gombi, which is popular. This underground pit can be constructed inside or outside the house, and it is considered to be cheap and economically feasible because they don't invest anything on it. They dig the ground and they laminate it with cow dung so that they can store the produce inside this underground pit. And farmers justify that the underground pit storage protect the grain from fire, from theft, and the insect pest, and it can also be protect the produce from domestic and wild animals. So with this perception that the farmer can store the produce in the underground pit. I hope this trend is also practiced in other African countries. The other storage structure which is common in Ethiopia are like Gombisa or this Gotara. It is actually in different name. Gombisa is in Afan Oromo and Gotara is in Amharic. This is one of the most common maize storage structure that is used by most of the farmers in Ethiopia. This is above ground. It is circular granary made by interweaving locally available material, mostly bamboo split by local Aristegian. So as you can see, two different kinds of Gotara. Some farmer can seal with cow dung, and some can have aerated based upon the type of the grain or forms of the grain they store, they can use the one which is laminated with cow dung for shelled maize, and the other with out lamination for with maize cob. So they have their own justification for having these two different kinds of gotaras, and the shape, the size, shape is, and the other varies from location to the location. And the other thing here where we can observe is like the farmer has the knowledge. They don't put the gotara in contact with the ground because it might like expose the produce to mite and other insects and others. So they put somehow above the ground, and this allows the air exchange, and it makes the produce safe, even though not totally guaranteed that it is not protecting the produce from the deterioration, but still taking up from the ground has its own advantage. It allows the migration of a gas exchange, and it reduces the spoilage of the produce. The other is Gumbi, Gota. These are similar with Gombisa, but here what makes different is the size, and in most cases it is used to store the shelled maize, and it is the size vary from place to place, and it depends from one part of the country to the other. There is a variation in terms of the shape, in terms of size, and the material that they use to construct this Gumbi. The other storage structure that is practiced by farmer in Ethiopia is the bag and polypropylene sack. This common practice in other African countries. And propylene sack is mostly used for the shield made because the size or the holding capacity of this propylene sack is like up to 100. So if it is with cob, few of the cob can fill. So the farmer use this propylene sack for shield made. And for this, before they store, they may use different practices to minimize the infestation. And the other point that we'll see the losses of made in the traditional storage structure. Even though the farmers practice different storage structure, this storage structure is not complete barrier for moisture, and it creates the conducive environment for the growth of insect, microorganisms, and so there is different losses associated with this traditional storage structure. Among that, insect infestation is one of the most challenges with the traditional storage structure. Some reports indicate that 30% of loss in maize are as a result of storage pest or storage insect pests. So 30% of the losses can be associated with the pest because of the effect of the traditional storage structure. They allow moisture to migrate from the environment to the storage, so that this creates conducive environment for the microorganisms. These traditional storage structures are liable for environmental factors, moisture, humidity, temperature, and this creates suitable condition, and then the pest can damage the produce. The other challenge associated with the traditional storage structure is mycotoxin contamination. The mycotoxin contamination is a challenge in traditional storage material. This makes the food unfit for human consumption, for animal, or beyond that, it can also cause certain health problems. Currently, some research findings indicate that mycotoxin, aflatoxin can be suspected as the cause for the cancer, or they are suspected to be carcinogenic. So it's not only the loss of the produce, but it is suspected to cause some health problem. So because of this aflatoxin contamination, about 25 to 40% of the cereal are lost or contaminated by mycotoxin, which are produced by the fungi. So these fungi, these mycotoxin are the byproducts of fungi, and these fungi can grow and reproduce and can damage the produce if it gets the moisture which is from the environment. So poor post-harvest practices and storage were the major cause for the maize contamination with aflatoxin, and report indicate that it's common for maize in sub-Saharan African countries as well with high severity. So we have seen different storage structure and the cause for loss of the maize. And the farmer also detect that there is a loss, and they use different means to overcome those losses during the storage. One of the storage management practice that have been exercised by the farmer indigenously, like cultural practice, this is associated with the separation of damaged and infected grain from the rest of the harvest, while they harvest and store their produce before they put into gotara or gumbi. They make a kind of sorting, separation based upon the infestation or not.
Original Medicare.
And the other practice is that they clean the storage structure before they put the new grain. So this is a cultural practice that the farmers use to minimize the loss of the maize during storage. Another means that the farmer exercise is botanical, and this is what are currently practiced because it is chemical free, that the farmer exercise to store the produce safe. And some research finding also confirming that some of those botanical used by farmers are very effective in preventing the storage pests. So this botanical can be prepared from locally available material, but the material or the plant that used for this purpose has the property of like repellent for the pests, and it have a deter fading, avoid oviposition on the plant or disrupt the behavior of and the physiological of the insect. So the farmers know which kind of plant has these properties, and they practice to minimize the pest during the storage. And some of those botanical have been approved at laboratory level, like it can 100% exhibit the growth of a weevil for a short period of time. So this practice is not practiced in Ethiopia, but also in other countries. Like study conducted in North Malawi and Zambia indicate most farmers were knowledgeable about the use of pesticidal plants in controlling pests of stored maize and beans. The other practice is mixing the grain or maize with wood ash, sand, and dust. So mixing approximately about 20% or more of wood ash with grain is reported to be effective in minimizing grain insect attack. The ash dust that is added or mixed with the seed has inhibiting insect behavior because it affects the movement, reproduction by blocking air and space between the porous parts of the maize. And the other is the abrasive nature of the ashes may desiccate the paste so that it can reduce the loss because of insects while the maize is mixed with wood ash, sand, and other dusties. Not only this, farmer has also the knowledge that they mix the maize with small size grains like millet, and in Ethiopia it is popular to mix with teff. This the mixing of maize with teff is like it protects the weevil or other insect pests. This is like a small size of teff grain fill micropores between the maize, and this hinders the movement of insects as well as cause shortage of movements in the container. So it hinder or inhibit the movement of the paste inside the storage while it is mixed because of the small size, and it creates compaction between the maize. And this is also proved at the laboratory level that blending maize with amaranth seeds also effective in minimizing storage paste. The other mechanism that the farmer exercise to keep the safety of the produce is hanging of the fire over the fire. So farmer store grain near kitchen where heat and smoke of burning firewood penetrate to keep food grain free from insect pests and infestation. This can perform by two ways. The first is it reduces the moisture of the produce, and the other is the smoke generated from the wood can have like pesticidal effect, so that it can kill pests that attack the produce. So farmers also believe like hanging their produce over the fire keep the safety of the quality of the seed. The other indigenous knowledge the farmer practice is storing and shelled maize cob that are completely covered by husk are less susceptible by insects compared with the one without shell or without cob. Farmers claim that shell grain were more susceptible to pest attack because while it is detached or shell from the cob, the microorganism may use the tips that detach from the cob as the entry for the pest and for the microorganism as well. So storing maize in a shell form seems to result in less pest attack compared with the one shield in terms of grain border. The other practice is like salt and hot pepper spray to their storage structure. This is a common practice that farmers use to minimize the loss of stored product because of infestation. The other mechanism that farmers apply to reduce storage loss is like selecting resistant variety for pests. So there is a variation in terms of the resistance of the seed to the storage pest. So farmers prefer the one with resistance for storage pests. So this is the farmers' indigenous knowledge that they practice, and it has been proved at a laboratory level that it is effectively minimizing the loss. So still, even though the farmer applies different management practices, the loss is very high. So some suggestions have been provided in this paper. Majority of the farmers in Ethiopia use traditional storage, which are ineffective in preserving the grain from damage. So improving the existing or the traditional grain storage method is very crucial to maintain the quality and the visibility of the seed. The other is creating awareness about the usage of improved grain storage, like metal silo, fixed bag, modified storage structure needed to be integrated with the existing storage structure. The other is providing the farmer with improved technologies that are affordable by small farm holder, like hermetic storage can be the possible option to overcome the losses of maize during storage. The other is like appropriate initial drying followed by moisture-proof storage can be suggested as a means to minimize the loss during storage. So generally, proper post-harvest handling practice combined with improved traditional storage structure are very important to store safe and quality seed for a long period of time. As a conclusion, like farmers have their own indigenous practice and knowledge to store the produce. So integrating the traditional knowledge and practice with modern technology is very crucial to reduce storage loss and ensuring food security. And attention is needed in upgrading the indigenous knowledge of farmer in storage management beside adopting modern technologies. So most of the time, like, we don't focus on what we have. We don't focus on the knowledge that our farmers have. Instead, we seek for knowledge and information from abroad, and integrating the abroad knowledge to the existing is sometimes challenging. So it's good to modify and work on the indigenous knowledge what we have to bring better preservation of the produce. So thank you for your attention. Maybe as a message, let's join hand in technology transfer to reduce food loss and ensure food security in our motherland, Africa. Thank you for your attention. If you have question and suggestion, you are welcome. Thank you.
Thank you so much, Haile, for that very insightful presentation. We definitely learned a lot. I did. There's so much that the farmers in Ethiopia are doing to help minimize this grain loss. I had an initial question here to ask about. You mentioned that despite all that innovation that the farmers are practicing, there's still a high degree of loss with their crops. Have the farmers resorted to maybe incorporating best practices from other indigenous communities? Like you cited some studies that have shown that farmers in other parts of Africa also have practices that they use. Has a combination of those practices showed any improvement, or do the farmers in Ethiopia typically practice only the indigenous methods that are native to them?
Thank you for your question. Actually, just this is the indigenous knowledge, but it does not mean that all farmers are applying those indigenous practices. Of course, in some cases, like determining the stage of harvesting and something like that, all farmers may use the knowledge that they get from the parents from generation to generation. But in most cases, like, even though this like mixing with small size seed is not practiced by all farmers across different ecology of the countries, but in some cases there is farmer practice these technologies to minimize the loss. Even though this knowledge exists in the farmer in terms of applying, in terms of practicing those technologies, still there is a big variation among the farmers. But if we like create awareness for the farmers and we inform them this is perfect and this can minimize the loss, is expected from concerned body that we have to let them know the traditional practice they use can prevent their produce. So currently what the farmer focus is, like, they use different chemical pesticides, even though they don't know at what concentration to use, at what dose they have to use, for how long to use, is something there is a gap in terms of information.
Thanks for clarifying. During the presentation, I saw we had a number of people joining the meeting. I'd like to invite you to engage with our presenter today. Feel free to unmute yourselves, turn on your cameras if you're comfortable, and just come into this conversation that we're having with Haile this afternoon.
I didn't hear you very well.
Oh, I was just inviting the other people on the call to feel free to join us in, inquiring further into your presentation. I see more people joined us than when we started.
Yeah, right. I prefer, like, these are the insights from Ethiopian perspective, and since we have colleagues from different African countries, I'm happy if we can share what their practice looks like in the respective country, so that we can reach on conclusion how we can bring forward the traditional existing knowledge for the better improvement in loss management.
All right. Emmanuel, can I go?
Yeah, please feel free.
All right. So Haile, I think you can unshare now so that we can see broader faces. Thank you.
Okay.
I first want to say thank you so much for this very insightful, enlightening, and educative presentation, because I don't know that there's anyone who has not been involved in agricultural practices. It doesn't have to be maize, it doesn't have to be grains, but I definitely know that most of us, especially those of us who come from Africa, it's a practice that we've been engaged in different ways and different capacities. So my question, I have a brief question about the method that you mentioned, the storage method of underground, and you said it can be built within the house or outside the house. Outside, I can understand. I'm just wondering, is it something that you have to design when you're building a house? Because I don't understand how you can include a storage system within the house that you already live in. Is it something that people plan to do in advance? Like you're building your structure, you cater for that as well? I just want to know how it works, especially the inside part of it.
How it's working, like, I don't know if we can clearly understand how our farmers at rural level construct their house. Most of the time, there is no concrete, it is ground, and it can easily dig. And the size is not that much big, because it depends on how much capacity that he or the farmer has. So based upon that, they dig the ground, because the ground is not concrete and not difficult to create a hole inside the house. That means it may be like 1 meter by meter square, so that they laminate inside the hole with cow dung, and they cover it and then make it safe. So I don't feel like it's that much difficult, because based upon the nature of the house that our rural community has, it's not that much complicated to prepare that hole inside the house.
Okay. I mean, I think then perhaps it also depends on the size, because I can't imagine, like I constructed a house where I have, let's say, 2-3 rooms, and where am I going to have space for? I'm imagining of the big granaries that you have outside. Perhaps these are smaller, you can do a smaller size depending on how much you're preserving. Oh, okay. All right, because I just try to imagine finding room in my house to have that big granary that is always outside. Inside, I just couldn't picture that. But that's really helpful. I definitely know that it's not hard to construct after, but the size is what I was wondering about. Where is that space inside the house to reconfigure and include a storage space? But it's definitely doable.
Yeah, the other thing, why they use that inside under the ground, is most of the time like the temperature is expected to be somehow cool, so that as temperature increase, the reproduction and of microorganism increase, so that they can control the microorganism while they do, besides the reason mentioned before.
Thank you. Somebody else, before I ask another one, I just want others to have a chance.
Yes, please.
Can I ask a question?
Yes, please go ahead.
Yeah.
Okay. First, thank you, Haile, for your good presentation. My question is there any comparative study like the Ethiopian traditional storage with like other African country, or even like in the country in Ethiopia compared to like different regions, like for example, the highland region with lowland, or the north side with south side, which has a better storage traditional method? Like, is there any comparative method?
Thank you, Ayele, for your question. Actually, while I prepared this literature review, I didn't see any information that have been compiled in this way. The reason is like to perform this experiment, it needs a lot of investment and it needs a lot of resources. And most of the study focuses on some parts of the country and the other doing the other parts of the country. And I haven't come across the comparison between different countries. But one thing what we can say that the loss is also depend on the ecology or the temperature of the environment. In some cases, the loss can be high where there is humidity and high temperature because these conditions create favorable environment for insect infestation for the growth of microorganisms. But in high altitude, the loss is suspected to be less because at this level, the growth of microorganism and other insect infestation is less. And at the same time, there is a variation in terms of management of the storage structure from one location to location in Ethiopia. So yeah, as you said, it needed further investigation to say like which countries practice farmer practice is good so that we can adopt from each other, and which places in Ethiopia performs good as compared to the other needs further investigation. So right now, I don't have any concrete data that can be enable to reach on conclusion to compare different practices.
Okay, thank you.
Okay, so I have a question. Haile, thank you so much for that wonderful presentation. So I want to ask, you did mention mostly on storing cereals. How do Ethiopians store vegetables and some other food categories?
Thank you. Yeah. In the issue associated with fresh produce, including fruit and vegetable, is very challenging in Ethiopia as well as in other African countries because this because of the nature of this produce, it needs some technologies, it needs cooling condition or refrigerated storage condition, and most of our farmers cannot afford those things. And I don't know any specific technology that the farmers are practicing to store their produce, but what I know is most of the time for potato, they store their produce inside they don't harvest until they need for intended purpose, and they store in the ground for potatoes. For other, they may use like a kind of crate which is made from wood to, especially during transportation from the farm to the market or from the farm to home, they use a kind of cricket. But as a community, maybe I don't remember or I don't recall, but I don't have any specific technology that is unique to farmers in Ethiopia to store their fruit and vegetables particularly. But there is traditional banana leaf. It is called false banana, or it is insect. People use traditionally to wrap it for very perishable produce. They wrap with the leaves of these insects to transport from one location to the other. Maybe you can also share us what you have from your respective countries in terms of. I know in Nigeria, like pot-in-pot technology is practiced. They put one pot in the other pot and they add sand between the two pots and add water to cool the produce. And there is also other technology that country practice, evaporative cooling system, which is developed from bricks.
When you mentioned Nigeria, I was like, I never told you I'm a Nigerian. That's my name gave me away.
Okay.
I'm from Nigeria.
Okay.
Yeah. Okay, so a follow-up question. During your talk, you also mentioned that farmers select resistant varieties. How is this done? I mean, how do you select those resistant crop varieties?
Yeah. In a specific farmer or community, we might have 4 or 5 different groups or varieties of maize. Most of the farmer might focus on the yield of the maize, and the other is something that develops through practice, not something that can decide today. For example, if they grow this year one variety of maize, after harvest they see what the quality, what the yield of the maize looks like. If they found it good, they continue with that. And if the yield the maize produced is less, if the quality of the maize during consumption is poor, if it is suspected high contaminated with insect, next year they don't use that variety and they change these varieties. So like in locally, it's not provided by a governmental organization, just the farmers exchange one variety among each other. Locally, they perform like that.
Okay.
So it is, they know through process, not something that I can identify at one time.
Okay. Thank you.
Thank you, okay.
Okay, looks like Leo has a question.
Oh, yeah. And I had it seemed interesting, some of the local technologies you were using. So you mentioned TEF, and then you mentioned amaranth. Is
Yeah.
that the leaves and then they grind them, and how is that used?
The amaranth and TEF is like they have very small size. The seed, not leaf.
Oh, the seed.
Yeah, they mix with maize. While it is mixed, the pores between the maize size, since the maize has larger size, there is a space between one seed of maize and the other. But while we mix it with those small seeds, the pores between the seed is compacted and it is filled with those small size, and micro insects and other microorganisms cannot easily move from one portion of the storage to the other because it is compacted to each other. You can imagine what the size of the amaranthus and TEFs looks like.
But the seed are tiny, right? For
yeah, so tiny. Yeah.
You must have a lot of it to be enough to.
Of course, in Ethiopia, this TEF is largely consumed, even more than maize. And almost every part of the country produce TEF, and it is mostly preferred grain in Ethiopia.
Okay, so it seemed like the biggest places the post-harvest losses were during harvest and in storage at home, right?
Yeah, most of the occur especially during the storage, because again the storage structure that we are using is not proof if for rain. It's no proof for moisture. If some heavy rain is happened, we can even lose the whole water of the storage unless we properly handle it. And since the farmer use it as a means of like consumption, they may store it more than 6 months, and until these 6 months there is infestation every day, and it may damage sometimes even the whole grain.
And no, but I don't remember for Malawi. I don't know of natural. People have talked about neem leaves and mixed with stuff. I don't know if they do it with storage, and I know some people have used ash for some things, but it's more like tubers and potatoes but I don't know of maize ways to indigenous methods to store maize, except just put it in the granary, but they leave it in the they don't shell it yet.
Definitely.
But once you shell it, then you're going for chemicals, thermic and that stuff. Okay, anyway, thanks. That was really interesting. It seems like there's something there for people to use indigenous methods. How widespread are they? What's the extent of use of these indigenous methods?
Yeah, right now these indigenous knowledge are very diminishing because, as I said, all the focus for even the educated person is only focusing the information what we get from abroad rather than focusing on what we have.
Yeah.
And compared with using chemical pesticides and local indigenous, somehow in performing the chemical pesticide is better, so that farmers are stopping the traditional knowledge and they're diverting toward the chemical pesticide. And one of the alarming issues regarding the chemical pesticide, particularly in Ethiopia, that they don't know how much dose is needed per gotara to put that chemical. And they don't get any instruction how to use that chemical. And sometimes chemical need withdrawal period. For example, if you add to the chemical, you might not supposed to consume until 3 or 6 months because of the chemical residue. But I'm worried that our farmers are considering those things. And even though we cannot detect the problem right now, through process we might have an issue with this chemical consumption.
Yeah, it can be dangerous. Wow, thank you.
Oh, thank you.
All right, Haile, I also wanted to ask a question about the bags. You mentioned about poly-something bags. That I think that's recent technology. I don't really think that's traditional. So I was talking, it's last week, I was talking to my mom. I don't know how the conversation dived into storing maize. And she was telling me that nowadays they have bags. I can't picture how they look like, but it's bags that you don't put any chemical, you don't do anything. The bags themselves are able to preserve the maize for a long period of time. And I'm like, that would be best, but I wonder how affordable they be if, for example, you are a larger scale farmer, it's not 2-3 bags that you need. So do you have any more information about what types of bags those are?
Yeah. That is what we call PICS bag. It is abbreviation actually, Purdue Improved Grain Storage Bag. So this bag is, as you said, it has like 3 layers and it is chemically treated. Once you properly tie it, it doesn't allow gas exchange between the produce and the environment. Once it is properly tied, the microorganism or insect cannot grow inside that package because it doesn't allow the oxygen inside the package. So it is also started practicing in Ethiopia somehow, but it's still like it's more than $2 per 1 bag, and it is the capacity is like up to 100 kilograms. So as you said, yes, it can keep the produce for a long time. And currently what is suggested for the farmer is this PICS bag.
Okay, so you said the chemically treated, is that dangerous as well? Like, is it not safe?
Right now in Ethiopia, we don't have any report that have been work on that if it is chemical is migrating from the packaging material to produce. And in another way, even though it is like a problem is there, it is advised by government, different NGOs to use those packaging material because it can extend the shelf life. So if we suddenly say that it has a problem, maybe those NGOs or governmental organizations that works on that might not interested to conduct such kind of investigation. But the issue is like, besides the chemical, once it is tied properly after it is filled with the produce, it is oxygen proof, or it is complete barrier for oxygen. So for insect to damage the grain, it needs oxygen to respire to reproduce to grow. So once it is tied, there is no oxygen inside except the oxygen during the tying of the bag. So
please go ahead.
Yeah, the problem with other storage structure is like it is not proof for moisture and oxygen. There is exchange of the oxygen and the moisture migrates from the environment to the packaging material because it's not proof. But this fixed bag is proof for moisture and oxygen, so that once it is tied properly, it did not allow the oxygen to enter to that bag.
I mean, that's wonderful. The way you explain it is the exact same way she was also explaining that in case of any insect going in their bags, they die. And I'm like, what is that? You're explaining something magic. I don't know what you're saying. Which bag can do that? So makes sense, and it's understandable now. Thank you.
Okay.
Do we have any more questions or comments? Okay, as we are waiting for others to chip in, I want to ask a question. You talked about chemicals that are used to repel insects. Are there other chemicals or plants used in repelling mycotoxin producing fungi?
Yes, actually, like the effectiveness of those plants has been performed in different way. It has been performed at the lab level by extracting the component which is responsible for repelling of insects and microorganisms. And the other form is as mentioned by Leo, they simply put the leaf inside the storage structure so that the smell or the compound which is generated by those leaves will repel microorganisms and insects. Yes, in some cases, like at laboratory level, it is investigated, and those botanical have the capacity to minimize or inhibit the growth of fungi as well, besides the pest.
Okay, that makes sense. Then I'm gonna ask a follow-up question. So when we are storing some of these products, is there any consideration on different morphological or physiological changes that may be occurring after storing? Let's say it has this amount of vitamin C before storing. Then after storing for 6 or 7 months, is the vitamin C level gonna reduce or increase? Like, is there any study on the change in the nutrient profile of the stored plants?
Of course, at the farmer level, where this might not be like a kind of thing we consider, but at the scientific level, there is some physiological and chemical change to the produce stored. In some cases, like it varies based upon the nature of the produce. I've seen some paper like, especially if we store the produce for a long time, the quality is increasing. Because for example, some anti-nutritional factor can be degraded because of storage. And in the same way, like some light sensitive vitamins can also be degraded during the storage. And at the farmer level, what is practiced is farmer always prefer the seed that is stored for a long time, because they suspect there is a change in quality of the produce. It's not from the nutritional perspective, but they simply consider it. For example, one thing was I really observed is like coffee seed or coffee beans. There is like a variation even in terms of the price. The coffee that is harvested this season and the coffee harvested in last season have the same price. The price of coffee for harvested last season is higher compared with the coffee that is harvested this season. So this work is for cereal as well.
Okay. Oh, thank you. Do you have any more questions? Well, Dr. Timaris, should we call it a day?
Yes, I think this has been wonderful. We might want to close here unless somebody has a question or comment. But I mean, this has been wonderful.
Okay. Oh, no, that's fine. Okay. Yeah, so thank you so much, Haile, for joining us. Personally, I learned a lot. Like, you reminded me some of those things that my grandmother was teaching me. Those times I was small, I do follow her to the farm, be like, okay, look at how these things are done. Like, I really enjoy that that refreshment. It's awesome. Thank you so much for joining us, and I guess we'll call it a day now.
Yeah. Yes, we
And
will.
maybe as a message, what I have is not only from the storage perspective. In every aspect of our life, our community and our people have their own indigenous knowledge.
Yeah, exactly.
So what I will really understand is, like, most of the time we don't want to focus on what we have, and we want to focus on the indigenous. For example, let's consider the current practice or current democracy. Every society in our country or wherever you go, Africa, they have their own means of solving issues, their own ways of governance and the like. But rather than seeking for the other, it's better if we behold and upgrade what we have so that we can improve the livelihood of our community.
Exactly.
This is what I have. I have also like one paper which is similar to this. The farmers' knowledge in Ethiopia in terms of wild edible plants and their nutritional contribution and medicinal value. So in that paper also I've found a lot of important information that our farmers or our community use in treating different diseases, in getting the required nutrients from different plants which is not known in the other parties. So as a scholar, maybe let's focus on what we have and let's work on upgrading what we have rather than borrowing things always from abroad. This is what I can say. Thank you.
Yeah.
Thank you. I definitely agree with you on that, because sometimes even if we try to ignore the systems or the methods that we have, usually it's what is available. Usually it's what can be accessible to our local communities. So the other methods sometimes are even not affordable to begin with. One, as you said, there's a danger in not using them properly, like chemicals. And the second one, they're not affordable. If you know that some herbs or some plants that you can use to preserve your food, that will be much better off than trying to stretch out.
Right.
Yeah, so I agree with you on that. And sometimes we're not conscious. We just go the easy way, what's trending, what's happening around. But as you said, as scholars, it's good to think back and say, where are we headed? What can we do better using the resources that we have within reach? So yeah, thank you so much. All right. Any more? Ife, are we good to go?
Zulu wants to say something.
Yeah, but that was really good. But what do you hope is that, you can find some local entrepreneurs who can take that up as a niche.
Yeah.
There's there's some people, even indigenous food. People just like the fast food. Somebody goes and opens a restaurant selling only in this indigenous food, and you market it as such. Maybe there's a market for people who want to go back to the indigenous ways. It's like organic pesticides and those kinds of things. So there might be a niche for that. that, you know, enlightened people might want to start going back. It will start slow, but we have to find creative ways to market the local technologies that we are. It might not be in the original form that we use it in the villages, in the rural areas, but we use the same knowledge to kind of create something that's kind of in between, but it's still basically organic. So.
Yeah. All right. So if are we good to say we can close the meeting officially, stop recording? If people want to stay a little bit and chat, we can allow that.
Yeah, sure, sure.
All right, then thank you so much. I just want to ask that so I can stop recording. And if people want to hang out, for example, I haven't seen Musa for a long time, we can hang out a little and then close it. All right.